Hello and welcome to episode 62 of the HamCorp Training Manual. In this episode, we will construct phase 1 of the nuclear power plant, consisting of the main tower with a familiar design and a simple IC2 nuclear reactor with thorium fuel rods. So I've decided to start with the ye old IC2 reactor. I never really fully got into this with IC2, so this is an opportunity for me to do that. And this actually reminds me of a new feature of 2.7. So you've seen these before, the any circuits. There's one for each voltage tier. And before, what I had to do was, say for example, I had access to workstations for EV circuits. And then after some progression, I get access to nanoprocessor assemblies. Previously, I had to go back to all of my recipes, every single one in here, and change workstation to nanoprocessor assembly. But now this any circuit is craftable. So you can take any of the EV tier circuits and put it in a forming press, and it creates an any circuit. And this one can be used in place of the circuit for any recipe. So instead of having to change every single occurrence of the circuit in all of these recipes, I would just have to change it once, which would be in the forming press recipe. So I just change it from workstation here to quantum processor or whatever. But the problem is I already have all of this kind of in place, and I still have to do this one last time that I go through every single recipe and change them out. I don't know though. It's a lot of effort for something that I've kind of already done. Maybe I'll do it for IV and beyond, but because I'm already making quantum processors and I've already upgraded all of these lower tiers to the maximum possible or the cheapest possible circuit, I don't think there's really a point in me going back to these ones. So for IV and beyond, I'll make the switch to the any circuit, but for EV and below, I'm just going to leave it kind of as it is in my system. So to get started, I'm going to have to make quite a few things. First off, the nuclear reactor itself and some fuel rods. Some reactor chambers to increase the capacity of the reactor, a hazmat suit because there's a radiation debuff, a bunch of heat vents. These are just components that are used in the reactor. I'm not sure how many I'm actually going to need, so I'm just going to start off with one of each, but I'm going to teach the recipe to AE2. I'm going to use the bronze-plated reinforced stone like the quest suggests, but I know that there are better options. There's probably better reinforced stones, but also you can use Thaumcraft and warded stones, which are indestructible. Ideally, I would be using that, but that's kind of against the theme and the danger of using nuclear power. Also need to make some heat exchangers, similar to the heat vents. Don't know how many I need, just gonna teach the recipes. And then there are kind of two choices of fuel rods. This one is for making sonarium, which I don't need yet, but I don't know. I think this one I'll skip for now, and I'll come back to this when I need it. And I'm gonna work on using thorium instead. And in fact, I may go back on this later, but I think I'm going to push for the quad fuel cells, just because why not go for the biggest one? This is an EV tier quest, and I'm an IV, so surely I'm able to do all of these, right? And as for this quest page, the powerful nuclear physics one, there's a giant wall of text that I need to read. I haven't done that yet, because I do want to finish all of these quests, just for the sake of the quests, if nothing else. Now for the nuclear reactor, we're going to need a nice big space to build a building. I was trying to record this as a time-lapse using my other computer, but the game kept crashing and it seems like it might be a hardware issue, so yeah, that's not happening. And I don't know when I'll be able to do time-lapses again because it crashes a lot and it makes it very hard to record. I've started digging out the space. The idea for what I want to build for a nuclear reactor is going to take up a lot of space. And also, remember this place? The old house, the old starter house with nothing in it. I'm gonna encase this in glass, and this is just going to be like a little museum. Now I'm gonna dig out the rest of the space and start building. Alright, I've cleared out a nice big area, and I decided I want to at least partially reuse one of my HamCorp designs. Looks pretty nice. I'm very happy with how this turned out. I've said before a few times this was my favorite design in HamCorp, so of course I'm just going to reuse this. However, I am going to expand on it. I want to have the big, like the nuclear cooling tower thingies, you know, with the big smoke cloud coming up. I want to put one over here and then one over here, and then maybe a third one here if I can fit it. But I don't want to build right now. This was enough. Taking those screenshots to make the time lapse was kind of burnt me out of building for a little bit. But luckily this is already quite a big space to work in. And I've brought over a chest full of all the stuff we're going to need. The hazmat suit I actually don't need because my nanosuit counts as a hazmat suit. And the reinforced stone, fuck it, we live dangerous. And as for the rest of the stuff, this is all required in this setup, which is kind of described here. You can also find it online. This is the 1920 EU per tick thorium reactor. That's not a lot. That's only 1 amp of EV, less even. But I thought it's a good place to get started just so I understand what's going on. Also, these quad fuel rods, they don't stack, but they also do. I don't know, it's weird. Like, these are stacking, but then when I try to combine it with this one, it doesn't stack. Like, when I pick it up again, it picks up 9? I don't know. Now let's put down this nuclear reactor. It's going to go right here in the center. Now this reactor, as it is, actually works. However, you can see that 6 of these columns are blocked out, and that's because we don't have all 6 reactor chambers. If we add one, it expands by 1 column, and if I add all 6, now we have access to the full reactor. Now the way these parts work, each of these components has a different effect when placed inside of the nuclear reactor. So let's start with the most obvious thing, the fuel source. I'm going to put these in last for kind of obvious reasons, but what happens is the fuel rods will slowly be consumed and they'll generate EU and they'll also generate heat. And the reactor has a maximum heat. If you reach that maximum heat, we no longer have HamCorp. All of these heat vents and heat exchangers and reactor plating, all of this is to help dissipate that heat as fast as or faster than it's generated. Another thing that's important about the fuel rods is, first of all, they're quad fuel rods, so inherently they're going to produce more than the single ones, but it's not 4 times more. I think it's 4 squared times more, but that could be wrong. So if you place 2 fuel sources next to each other inside the nuclear reactor, let's say this produced 1 EU per tick, in total, we would not be producing 2 EU per tick, but we'd be making 4. And the reason this happens is nuclear physics kind of being simulated in the game. It's basically when a radioactive element decays, it releases neutrons, and then the neutrons go and hit other atoms, and then that causes them to decay, and then that produces more neutrons, and so on and so on. So you kind of have a chain reaction, and if you're making too many neutrons on average, you're going to have an explosion. So you don't want to bunch these up too much. You do to some extent because it multiplies the power output along with the heat, but if you do it too much, then it's going to be very hard to dissipate the heat. The reactor platings, these increase the maximum temperature of the reactor, and they also reduce the explosion radius, but hopefully we never see that effect. The heat exchangers don't dissipate heat, they just help the heat kind of transfer around, and it only transfers heat between components, because I'll come to the components, but this doesn't take heat away from the reactor. It's just within the reactor, between the components, it allows for heat to be transferred. And then finally, the heat vents themselves. These are the most important. Each vent removes a certain amount of heat from the reactor, and it does that by absorbing the heat into itself and then dissipating some of that heat. So it just kind of voids the heat. But it absorbs more heat than it dissipates. So that's why you need these heat exchangers to help kind of distribute the load across multiple heat vents. Oh, also, I didn't talk about the component heat vents. These ones just dissipate heat from each surrounding component. So if it was arranged like this heat vent would help dissipate heat from the surrounding 4 overclocked heat vents. But anyway, the designs for this can be very complicated, and it could be a fun exercise to figure one out yourself at the risk of everything. But I've decided not to do that, and instead I'm going to copy a design that is both suggested by the book and also is available online. Alright, here is the setup. This needed 2 heat exchangers, 16 quad fuel cells, 21 overclocked heat vents, and 3 reactor platings. Be aware that this only works with thorium, I think. I think if you do like uranium quad cells, this is not going to work. It might blow up. But here we are. This is the reactor, and now we can put in all of these cells, and then we're good. It does need a lever to turn on the reactor. Alright, here we go. We are now generating 1920 EU per tick, and the core temp is 0%, which is great. Of course, in this moment, I'm just voiding all of this power because there's no cable leading out of this reactor. Don't really care. I still have to dig out the tunnel and stuff, but I think I'm gonna let this run because I want the depleted fuel cells. So I'm not too bothered about the wasted power at the moment, but this is just the very first reactor, and it is not powerful enough for what we need. We are going to get some lutetium from the depleted thorium quad fuel cells, so that's good. But now I think it's time we move on to a bigger source of power, which is the fluid nuke. Now the fluid nuke is a little different than the regular nuke. This one just generates power, just out of nothing. Like, well, not out of this thorium somehow, like you just get power, which is not how it works in real life. In real life, the heat that's generated here goes into heating up water, and then the water is sent to run turbines, basically. And that's kind of what's happening here as well. So here in the fluid nuke, we're going to be heating up coolant, and this makes hot coolant. And the hot coolant can be turned into energy through steam or through superheated steam. And indeed, this is worth doing because the regular nukes have a 50% penalty to EU per tick. So let's put together this fluid nuke. I'll gather the materials while this reactor is running, and I'll also connect up the power to our power grid, just so we're not completely wasting this. And I'll see you when I have all the fluid nuke stuff. I'm back. I don't have the fluid nuke components yet. I'm still working on that. But I changed the design here a little bit. So now I've plugged it into the rest of our system. And now there's this green cable that's supposed to be like a uranium fuel rod that goes down. And I kind of made it look like Cherenkov radiation. And Cherenkov radiation is really cool because it happens in a nuclear reactor when the electrons that are coming off of the atoms go faster than the speed of light in the medium. But it's still slower than the speed of light in vacuum, so we're not like breaking physics. So you kind of get like a sonic boom, except it's for light. And then that results in this like blue glow at the bottom of nuclear reactors. It's really cool, and I like this effect a lot. Now I have the blocks to build a fluid nuke, but I'm not going to do that yet, because there's quite a bit more infrastructure that needs to be set up. So the way fluid nukes work is a little bit different. Actually, quite a bit different. Currently, we have our reactor. The reactor is on, consuming thorium, and it's just straight up outputting power. Now fluid nukes don't do this. Fluid nukes will consume our fuel, the same way that it's being consumed here. And then it also consumes coolant and outputs hot coolant. Now the hot coolant is sent to a large heat exchanger where it's essentially crafted with distilled water to make either steam or superheated steam based on how many heat units you're making. And according to this quest, we want a setup above 800 heat units so that we get superheated steam because that's more efficient. Once we get superheated steam, we need 2 more turbines. We're going to need the large HP steam turbine, which is for the superheated steam, and that will convert the superheated steam into regular steam and also provide some power. And then the regular steam needs to go into a large steam turbine as usual, and that gets turned into power. At some point in this process, you also get the distilled water back. I don't know exactly where, but also if you run out of distilled water, then things can explode. We're going to need a lot of redstone signaling to turn things on and off, because if we run out of coolant, I imagine the fluid nuke is going to explode because it's coolant. So if we're not able to process this hot coolant back into regular coolant fast enough, that is also a problem. This quest suggests 2 potential setups. They both use uranium instead of thorium. So I think I am going to just let this thorium keep going. And I'll make a new nuclear reactor with new components. And I'll probably just move this one off to the side somewhere because this isn't going to be our primary nuclear reactor. This is mainly just going to be for making lutetium. But anyway, the quest suggests 2 potential setups. One that needs iridium and one that doesn't. They're very comparable EU per tick. The one that doesn't use iridium is actually a little bit better, but it says it's harder to automate. And I have iridium, so I'm just going to make my life easy and do that one. But it's going to be a while before I'm done crafting all these multi-blocks. Thank you for watching this episode of the HamCorp Training Manual. In the next episode, we will continue working on nuclear power by upgrading to a fluid nuke that processes uranium. Depending on how long it takes, our thorium may be done, allowing us to start collecting lutetium. If you would like blueprints of the buildings to build in your own HamCorp subsidiary universe, please come by the Discord and ask. See you next time.